Right, good day. Today we're gonna be looking at drawing a line graph, which essentially should look something like this. I will be taking you through a step-by-step, well, not really instructions, but a step-by-step tutorial on how to draw a proper line graph so that you don't lose marks in your test and exams because of a line graph. A line graph is what I like to call SASA marks. You absolutely cannot lose marks when it comes to this, right? Good. So I always tell each and every learner that I teach this that the first thing you need to look at when presented with the problem statement and data here is that you need to look at your variables first. Your variables. So remember, you need to identify your independent variables, dependent variables, and your dependent variable from the information that you were given. So let's quickly look at this easy information that we're given right here. It says that Emma measured her plant's growth for 5 weeks, right? So how do we elicit in variables from here? So usually it's easier to look at the graph, the table presented, because all of the results will be in the table. But look at the statement; it will tell you. So what I usually say to my kids, look at what is dependent on what. First, identify variables. You don't know which one is independent or dependent, but look at variables. Emma measured what? Her plant's growth. So a plant's growth, the growth of a plant basically, is a variable over 5 weeks. So for a certain amount of time. So the time in weeks basically is a variable. So we need to take these two, 1 and 2, and then identify which one is the dependent variable and which one is the independent variable. I always say, after you identify your variable, say to yourself, which one is dependent on which from the two variables? So, a plant's growth, the growth of a plant, is it dependent on the time in weeks? Or time in weeks is dependent on plant's growth? I mean, it should be a no-brainer that time will forever pass, right? Whether plants are growing or not, time will pass. So time does not depend on growth. But the growth of a plant will depend on how long it has been growing, right? For example, if in week 1 a plant is 2 centimeters, we're expecting it to grow by week 2 to 5 centimeters. So that makes the weeks or the week the independent variable. So the week is the independent variable, and then the height, that basically is the growth. The height of the plant in centimeters. Make sure if you are given a unit, you write it the way it is. The height is dependent on the weeks. So in week 1 it was 2 centimeters. In week 2 it was 5 centimeters. Now that you have identified your variables, we are well on course to drawing our line graph. Now, what do we do? First things first, you cannot draw anything in science without a heading. So usually when we mark, we'll say caption or heading. We're gonna give you a mark for it, right? Good. What is the heading? They say Emma measured her plant's growth for 5 weeks. This is a line graph representing plant, a plant's growth, or you can say plant growth for 5 weeks. We're done. Mark number 1, SASA marks. We're getting marks now. Now we can go and draw. What are we drawing? Our axis. Take your ruler, draw a very straight line going down and going to the side. Now we draw our axis. This is your y axis. This is your x axis. right? These are axes. This is not the graph. So you get no marks for drawing these lines. You just need to know which one is which. So the vertical one is the y-axis. The horizontal one, which is this one over here, is the x-axis. Now, which variable goes on which axis? Now we need to know how to label. So the second mark that you're going to get is for labeling. Now we need to know how to label. So we need to know how to label our graph. So which variable? Remember, this is the independent variable and this is the dependent variable. The dependent variable goes on the y-axis and the independent variable always goes on the x-axis. I always write this to my children so that they don't forget. They always laugh at me for this. I am always independent from my x. So the independent variable goes on the x-axis. So what is our independent variable? Our independent variable is the number of weeks, the weeks. Ne? Good. And then our dependent variable is height. You write it in full and in centimeters. Good. Usually we do not allow the learners to write it without the actual unit. Let me write it further. So that will be your height in centimeters. Good. Now you got your label mark. The third mark, SASA mark, for free. You haven't even started drawing the graph. You need your units, right? You need your units. So we start on the y-axis. This is the origin of your graph. 0 is here. And then once you have this 0 here, this applies to both axes. You can't put another 0 here and say 0, 1, 2. We don't do that here. We don't do that here. 0 for both axes is on the origin of the graph. Great. Now let's choose a scale. So how do you choose a scale? You look at the numbers, the lowest number and the highest number. Which scale can you choose that will incorporate all of these numbers? And remember, your scale must be consistent. You can't start here by saying 2 and then 6, 24. It's not consistent. If you're saying 2 and you add by another, that means from 0 to 2, you added by 2. So that means here it must be 4. You understand? So your scale must always be consistent. If you started with 1, that means you're going to add another 1, it's going to be 2, 3, 4, and so forth. Next. Great. Now, let's start. What scale can we use to incorporate all of these numbers? Up to 14. You can even use 1, 2, 3, if you have the space. 4, scale line, 5, 6, 7, 8, 9, 10. I'm running out of space, so I'm going to increase. Let me take off my heading for now. That will be 11, 12. Let's increase our line. Remember, my lines are straight, right? Let's move on and add some more. 13. And then right on the line. 14. That's the last one. And just for the sake of it, we'll put 15 over there. Notice that my scale lines are exactly the same space apart. Great. Now we've figured out the scale for the y-axis, and then when we look at the x-axis, we have week 1 up to 5, so we can easily say week 1, week 2, week 3, week 4, and then week 5. That is simple and easy, right? Good. Now that we have the scale and all I'll lose a scale mark if I don't put the scale line over here. Now we have our scale. Now it's time to draw a line graph. We say we're drawing a line graph. So you're going to get a mark for the correct type of graph, right? And then later on for plotting. That's a total of 6 marks. 6 SASA marks courtesy of the Department of Education for free, right? Great. Now let's plot the graph. How do we plot the graph? we look at in week 1, right? In week 1, we look at week 1. What was the height of the plant in week 1? That was 2 centimeters. Put a dot here. Some people like X. I like dots. They're cleaner for me. Great. In week 2, the plant was 5 centimeters. Around here. In week 3, the plant was 8 centimeters. It's growing exponentially in height. Then in week 4, it was 11 centimeters. 11 centimeters, week 4. Here we go, right over there. And then week 5, it was 14 centimeters in week 5. In week 5, it was 14 centimeters. And then what do? When you've dotted your lines, is then that you plot your graph, right? You plot your graph. And here we go. That is your line graph. You've basically plotted your line graph and you get all of your 6 marks for free, right? Good. Now, here's a practice question for you right now. So there's a practice question for you. I'm giving you data over here. I'm going to give you data over here. Right. So, for you to practice, I'm therefore going to tell you Thabo runs 100-meter sprint, right? His speed was recorded. No, not his speed, sorry, excuse me. His heart rate. His heart rate was recorded every 20 meters. Meaning in 100 meters, you'll have 5 readings. So, this is Thabo. He's running a 100-meter sprint. And then his speed his heart rate was recorded every 20 meters. The results are shown below. Right. So what is our column headings here? So we are gonna have what? We are gonna have the distance in meters. And then we are going to have his heart rate in beats per minute. So at 20 meters, his heart rate was 70 beats per minute. At 40 meters, his heart rate was 90 beats per minute. At 60 meters, his heart rate was 95 beats per minute. At 80 meters, his heart rate was 100 beats per minute. And at 100 meters, his heart rate was still 100 beats per minute. Draw a line graph representing the results of Thabo's sprint. We will do corrections in the next video when I explain how to draw a bar graph. We will start with correcting this work. That concludes our lesson on drawing line